Hi everyone, just wanted to take a little bit of time to talk about how to prove triangles congruent. And we're continuing on with our different methods. So last week we had spoken about side, side, side. And this week, today we're going to start off with side, angle, side. So it's very similar to the prior method. Most of the techniques that we've used last week, we will come back and look at again, except this time now we have an angle instead of a third side. So what is our actual goal? So our objectives here are to prove that the triangles are congruent using the side, angle, side postulate, and then we're going to prove parts are congruent using Cpctc, which again, for a quick reminder, was corresponding parts of congruent triangles are congruent. All right, so what actually is the side, angle, side postulate, which, if you guessed, is we can prove that two triangles are congruent if we know that we have two sets of sides that are congruent. So this side and this side, and then this side and this side. And then if the angle between them, all right, so this angle over here, that angle over there, not this one over here and this one out here, that would be angle, side, side, which is not what we're looking for. We're looking for in order, side, angle, side. Okay, side, angle, side. So the angle needs to be between them. And if we have that, we can say that these two triangles are congruent. So let's look at an example of this proof in action, or this method in action. So we have our given information, which again, remember, you are always going to start with our given. We have two pieces of information that are given. We are given that CD, side CD, is bisecting angle ABC. So I'm sorry, ACB. So this right here, these are being bisected. And then AC, side AC, is congruent to side BC, segment BC. All right, so I'm going to mark that off just so we remember. All right, so we're going to write down our two givens. We're given these two pieces of information. That's step 1 and 2. And then what do we know about something being an angle bisector? Well, it's kind of in the name, right? It's bisected, it's being cut in half, split into two. So an angle bisector, when it's when it exists, it cuts an angle into two congruent parts. So we know that these two angles up here, these are congruent. All right. Finally, what do we have? We have this side, side CD. Now that's a shared side, right? So whenever you have a shared side like this, we can use that process, that property, the reflexive postulate or property that we've seen before, right? That was the thing I was joking about. You know, this thing is exactly this thing. The floor is floor. So CD, segment CD is congruent to segment CD, all right? So that is how we're getting our side, our angle, and our side. And you can see we have a side, an angle, and a side, right? A side, an angle, and a side. And then finally, the last thing we're going to say is that these two triangles are congruent. This is supposed to be the triangle symbol. Didn't come through. So it's side, angle, side. All right? And that's all there is to it. And again, a lot of these are going to be very similar. So once you get used to the format, it won't be too bad. All right. So let's look at this one. VY, segment VY, bisects angle WVX. All right, WVX, okay. Yeah, segment VY bisects angle WVX. Complete the proof to show that these two triangles are congruent. Okay, so this is what we're trying to prove, and this is what we're given. All right, and we are also given this information based on our picture. Okay, so that's where this statement's coming from. All right, so how am I able to tell that these two angles right here are congruent? Because it's saying that's our next step. Well, what did we use last time? We said when we have an angle bisector, it splits it into two equal parts, right? So what was our reasoning there? Definition of an angle bisector. All right. So that's all we're going to do. So this is our definition of an angle bisector. And I'm lazy, so I'm just going to shorthand. Okay, definition of an angle bisector. Now, we have VY is congruent to VY. Well, what's that? That is this shared side. And whenever we have a shared side, that is the reflexive property. All right. So finally, we end with that the triangles are congruent because, again, we have a side, an angle, and a side. Now, many of these proofs are going to be similar. They won't all be exactly the same, but they will be similar. See, these ones are similar to the one that we just looked at. It's just kind of flipped, right? So just because the triangle's upside down now doesn't mean anything else. All right, let's do another one. All right, this one's a little bit tougher because we don't directly have all of the statements and reasons listed. So let's start ourselves off with our statements and then our reasons. Okay, so we have a decent amount of givens here. So I'm just going to write them all in one step. So it's perpendicular to DC. We have the AC, and you could split these up into a couple if you so desired. You know what? Let's do that. Let's just write these as three separate givens. All right. So I'm going to mark down everything that we know. These are all. This is given. Given. And a given. All right. So we know this. What do we know? So we know that side AB is congruent to side DC. And we know that these two are perpendicular, right? So what does it mean for lines to be perpendicular? Well, when lines are perpendicular, we know they meet at right angles. So because these are perpendicular, we can say that these two angles right here are going to be right angles, right? So angle DCA and angle BAC are right. Well, what do I know about, where does that come from? That just comes from the perpendicular lines. Okay, and then don't forget that symbol just means perpendicular. If you want to write perp instead of that, that's perfectly fine. Okay, so 5. Well, what do we know about all right angles? Right angles are all 90 degrees, and therefore, if I have multiple angles that are right, they're congruent to each other. So angle DCA is going to be congruent to angle BAC. And that's just because all right angles are congruent. All right. Now, we have a side, an angle, and oh, look at this. We have a shared side again. All right. So whenever you have the shared side, it's just going to be the reflexive property. By the way, it doesn't matter which order I put these in. Obviously, you should put 4 and then 5. You know what I mean by that? Like we should say that they're right and then they're congruent. But it didn't matter if I did the reflexive first. Okay. So that is from reflexive. All right, my reflexive property. And then finally, what were we actually trying to prove? Well, we were actually trying to prove that triangle DCA was congruent to triangle BAC. And why are we trying to do that? Or how were we able to do that? I should say we were using side, angle, side. All right. So as you can tell, a lot of the same things are coming up. We're still using reflexive property a lot. Again, sides are kind of hard to get if we don't directly have like a midpoint or something like that. But ultimately, you're going to see a lot of reflexive, a lot of perpendicular lines, right angles, vertical angles are another thing that comes up a lot. Angle bisectors, stuff like that. All right, last thing to do. Don't forget that you can use Cpctc. So after you've proven two triangles are congruent, you can use Cpctc to say that an angle or a side is congruent to another angle or side in here. They do have to be the ones that line up, right? So remember what we were talking about, the L lines up with the O and the B lines up with the G and the G lines up with the B. That's what I mean by that. They have to be corresponding, but if they're corresponding, you can still use that. All right. So on this one in particular, we were given that these two sides were congruent, and we were given that angle LBG, and angle OGB were congruent. Then look at that, we have a shared side, so we have a side angle side. And then we were able to say from that that these two angles were congruent because these are the corresponding angles, right? They're the corresponding. We didn't just pick two random ones, they're corresponding. All right, let's do one of those. This one won't be long. So we already have our statements started to be listed here, statements and reasons. All right, so we are given, well, we're given that these are triangles. Don't worry about that. So we are given that TV is congruent to WV. All right, so TV is congruent to WV. And what else are we given? We're given that TW, segment TW, bisects UX. Okay. That's another given. Okay, so remember, what does bisects mean? It cuts it in half. We're cutting a segment in half now. So this segment, VX, is cut in half. So that means that these two right here are going to be the same parts. Okay, because V is the middle. All right. So we have UV is congruent to XV. And all that is, that just comes from what it means to be a bisector. That's the definition of a bisector. Okay. Now, what do we know? Okay, so we have a side, side and side. So we have two sides, but we have no angles. Well, luckily, these are vertical angles. So we know that vertical angles are congruent. So that's how I'm going to get my next angle. And this is a very common way to be able to get angles. So remember, whenever you have that like cross shape there, you can say that the two angles in the middle are going to be congruent because of the vertical angle theorem. All right, so now I know that those two angles are congruent. That's the vertical angle theorem. All right, so now I have, well, what do I have now? I have that the angles are congruent, so I can say that the triangles are congruent because I have a side, an angle, and a side. So what do I have? TVU is congruent, and I have to be careful. I have to line them up. So TVU, right? I have to go from the 1 to the middle to the 2. 1, middle, 2. So WVX. And that's from side, angle, side. But we're not done yet because we are being asked to prove that these two are congruent. We are able to say that. And the reason we are able to say that is because of Cpctc. All right. So these are some very common structures and setups for us to look at when we're dealing with proving triangles are congruent and then parts are congruent. All right. Okay. So please let me know if you have any questions. And if not, have a lovely day. Bye.